In this video, we will search, sort, and paginate using Deno and MySQL. Before we start building the app, I would like to remind you that this video can be combined with other videos. So if you want to use Deno with any of these front-end frameworks, or Deno with MySQL or MongoDB, I provided some links in the description of this video. If you don't want to combine them, don't worry, the combinations are optional. Now let's start building the app, and also make sure to check scalablescripts.com. Now let's create the Deno project. Here is deno.land, the main page of Deno, and here is my empty folder. We will create the project. So I'm using PHP Storm here, but you can use Visual Studio Code, it is the same. Here I'll create a TypeScript file, app.ts, and we want to add some Deno code here. So the usual example, before you install Deno, of course, if you haven't installed it, use one of these commands. And I will copy this code, paste it here, and this is the first Deno project, and we can run it by using Deno run app.ts. So Deno is secure by default, and if you want to use the port to access localhost, we need the flag allownet. So to run this app, run Deno run allownet app.ts, and now we are listening to port 8000. Hello world. So everything is correct. Now I will change again this code, because we will be using third-party modules, and in the third-party modules I will write here awk, and this is the package that I want. And to run an application using awk, so I'll copy this code here, and I will change this. So it is the same, but awk provides more functionality. So if I run this again, it's running because we didn't add here the console log. So I will add a console log listening to port 8000. Note that when I save, the app doesn't refresh. To change this behavior, I will close the terminal now, and I will run the same thing, but with the watch flag. So if I do it like this, if I add an exclamation point here, save, and file change detected, restarting, and listening to port 8000. So during development is good to add the watch flag, and this will be the same. So we are returning hello world here, and now let's prepare the app. So I'll go back to the third-party modules, and I will add course. So first, what is course? Course stands from cross-origin resource sharing. If you want to use this app with another frontend, you can use it, but you will have course problems. So you have to add this package to prevent the course problems. So I'll import it here, import from this URL like this, and I will import awk course. So this app will run on port 8000, and the frontend will run on a different port, and the browser will prevent that. And if you want the browser to allow that, you have to add the course. So I will add it here, app use awk course, and inside I will add the origin. And the origin will be a regular expression here. So since we will use multiple frontends, so this will be like this. So it will be localhost. This in front says that we can have anything. So this will be HTTP or HTTPS. Localhost with the port 3000 for React, 4200 for Angular, and 8080 for Vue, and $sign. So that's it. If we add this origin, all the other frontends will consume the endpoints here. So we need to add also the routes. So we can add here a router, and we can create the router here is equal to new router, and I will use the endpoints later. So first our app will use a router that routes, and it will use the allowed methods, and that's it. So we added the necessary configuration. We will add later the routes, but now we need to connect with the database. So let's connect with the database. In this example, we will use MySQL, and for the database, I will install a package called Cotton. So this is the package that I want. Go to the Getting Started guide. So I'll open it in a new tab here. And we need to go to migrations here, and we need to install the Cotton CLI. So run this command, and I will close the terminal, run this command, and the latest version is 0.5 here. And for me it will not install it because I already have the installation. You may install it directly, but for my case I have to use force here. So -F. And I need to export this path so I can use Cotton CLI directly. So Cotton, we can see that I have this command, and this Cotton has some functionality regarding migrations here. So we installed Cotton, and now we need to connect with our database. So I will connect with my local MySQL database. So I will open this tool to connect with database here. If you don't have this, you can use MySQL Workbench. It will work the same. So my user is root, my password is root, and that's it. So I will test the connection. So did I put the right password? So I always have this problem of the time zone, so I will put UTC here, and this will work fine. So I connected with the database. I have an empty database here, and now what we want to do is to add some tables in this database. So to add tables, we have the migrations command. First, we have to add an ORM config file, ORM config.json. This is needed because this will listen to this file to connect with our local database. Here I will paste this JSON. So we need to connect with MySQL. This is a port, this is a database, localhost, username and password. So this is pretty basic. And with this now, we can add a migration. So to add a migration, run cotton migration, create, I will call a table, create, we need name here, create products table. So as we can see, the CLI has run, and now we have a folder migrations, and inside we have a create products table. So inside here we need to run the command to create the table in our database. So let's do it. First we need to await here schema create table, and the table is products, and the table will be passed as a parameter here, and let's add the columns. So the first one is the ID, the second one is a varchar of title, so the product will have a title. We need the description, we need the image, so description can be text, and the last one is an integer price. So this is our table, and the down command is await schema drop table products, and that's it. So now we want to run this command. First I will change the version here to 0.7.5 because the 0.2 version has an error. And now let's run the command. To run the command, run cotton migration up. So this will have a problem. Table Deno search migration doesn't exist. Now it's not solved yet. I'm not sure why. We have to manually create a table called migrations, and this table, so we'll open this, we'll have an ID, auto increment primary key, we need to have the name, which is a varchar 255, and we need to add also the batch, which is an ID. So these are all the columns that we need. So ID, primary key, name and batch. After we add this table, we can run our migration. So cotton migration up, and this is migrated successfully. So we have our table products here, and of course the migration is updated here. So we successfully added the table in our database, but we need to add some data here. We don't have any values to show if we add the endpoints. So what I will do is I will drop again the table. So I'll close this and run cotton migration down. So we reverted the table, and now we don't have the products table. So what I want to do now is I want to create again the table here, and after we create the table, I want to populate the table. So I will add some fake data to the table. So to add fake data, let's add another library, third-party modules, Deno faker. So we need this package, and I will import it here. So we have the faker library, and what I want to do right now, after we create a table, I'll create 50 products. So for I, so let I equals to 0, I less than 50, I plus plus, and we need to create values. So we need to create records. To create the records, the schema has an option. So with schema query, we can run an SQL query. And what I want to run here is I will run insert into products that has columns title, description, image, and price. I will add the values that we want to add. So what are the values that we want to add? We want to add it in single quotes because that is what MySQL wants. And inside I'll put faker lorem words 2. So this is for the title. For the description, I'll open it in a new line. So I'll copy this. For the description, 10 words. Then for the image, I will not use lorem ipsum. I will use an image URL here, like this. And the last one is price, which is a random integer. So random number 100 here. So this is a random integer till 100. So if I run this, we will insert 50 products and it will be correct. But I know a better way, since this will connect 50 times to our MySQL database, and every time it will insert single values. A better solution is to run the query only once, because we can insert them simultaneously. So what I will do is I will await this query outside, and here we need to create, I will create here an array of values. And when we create 50 products, I will cut this. So do I need to cut it till here? And I will add the values here. Push this. So let me see if everything is correct. So we are pushing open brackets here. So let me format everything to check for mistakes. We don't need this one, and that's it. So we created an array. This will be 50 values. So this will be an array with 50 of these open brackets values here. And when I insert right now, I will pass here values join with the comma. So we can add here a comma directly, but since we need to remove it for the last item, this is a better way. Let's run this. Cotton migration up again. So this is migrated. And now if we open the database, we have 50 products and the table is created. So that is what we wanted. Now let's run the Deno app, the Deno command again, which is the right command. Not this one, but with the watch. So we need also to add unstable here. And our app is running. So now we connected with, actually we didn't connect with the database, so we have a table that has data that we want to return in our APIs. And to connect with the database, I will create here another folder, repositories. And inside I will create a TypeScript file called repository. So this will be export abstract class repository. Why abstract? I will explain it later. So this is the main repository class, and we can reuse this class with other repositories, which I will show later. So first we need the client here. I'll create a method client, and here we need to I will copy first this Kotlin URL. On top I will add not schema but connect, and here we have to return with connect, and inside here in the connect I'll put this JSON and I will paste it here. So this is a connection to our database, and let's also have a method find, and we need to get the database, which is with this client. So I will use this client here. We got to the database, and we will return values. So with database table the table is products, and execute. So this will get all the values from our database. So for the moment I will remove the abstract and I will add it later. So let's get our first products, and I will re-add the abstract. So let's add the route here, app, not app, sorry, router, a get request to API/products/frontend. And this will accept an asynchronous function, and this function will return, so we need to import here router context. This is an object of type of router context, and inside the router context we want only the response. So let's get our repository, which is equal to new repository. Don't forget also to import it, and response body is equal to with repository find, and that's it. Let's test this endpoint, and to test it I will use Postman, so make sure to download and install Postman. The endpoint is HTTP localhost port 8000/API/products/frontend, and we got all our products here, so all 50 of them. So this works fine, and now I will change this repository to an abstract class. And if I change this to an abstract class, we will have an error here, because we cannot instantiate abstract classes. Abstract classes can only be extended. So, and why we need to make it abstract? because in the repository here, I will create a product repository, and this will be the class that will extend this abstract, this repository like this. So we want to use this product repository instead of the repository, so I'll change this to product repository. And in our table here, this is specific to the products, but we have to add this specific thing to the product repository here. And to do that, in the repository abstract class here, I will add, if we declare a class abstract, we have the option to add also abstract methods. So I'll add here abstract table, which returns a string. So this function doesn't need to be instantiated here. This needs to be instantiated in this product repository, which we have a problem right now because we have to implement it. And for the table here, I will remove the products and I will use this table like this. So with this, this repository doesn't know anything about the classes that extend this. And in the product repository, I will add the members that are missing, which is this table, returns a string, and this will return products here. And that's it. So in our app.ts now, we changed that to product repository, and the repository will find. So now this product repository will have access to the find method, as we can see here, and everything will work the same. So what is the benefit here? Let's say you want to create a user repository, another table of user, for example. The only thing that you need to do is to create, of course, you need to create it in another file, but the user repository will be like this. And you don't need to do anything else, because this will get all these methods that are needed for the user. So this is how object-oriented works. And if you want to learn more, I have a course regarding Deno, which I use a lot of object-oriented concepts. You can check that in the description of this video. So the front-end endpoint is completed. Now let's add the backend one, which is almost similar. And here I won't find all. I'll add another method, which is I'll call it getBuilder, and it is almost similar as this, but I will not execute the query, since I will return it directly like this, because we will add extra conditions and then execute. So this is a function, and in our app.ts I'll get the query, so which is equal to repository getBuilder, and in the end we'll await query execute. So we have a problem here because we need to wait here, and this is correct. Now this will return the same data as the product frontend. So if I change this to backend, we are returning the same data. And now we need to search. So to search, I will add here, we can add it here, search is equal to something. Or in Postman, we can add it directly here. So if I want to search by this word here, I want to filter the items with this title that contains this word. So let's do it now. So to first we have to get the search value, and to get the search value we have to add here also the request. And to get the search value, I'll get it. Search is equal to request URL search params get the search that we added. By default, it will be empty if it is not provided. Now I will make the condition. If the search is set, then we have to filter this query. So we have to add the where condition. And the where condition will be query where title will like this search value. And to do a like condition, I will go to the builder and I will import, I will copy this and I will import it here. We need to import Q here. So the like query is Q dot like, and like this. And inside I'll put 2 percentages, and inside I will add the search value. So this is the like query. These percentages mean that you can add anything in the prefix or suffix, so it doesn't matter. This means that the title will contain this string. So if I do it like this, if I send the request now, we can see that this item is returned, and also this, all these all these products that are returned have this word inside. So this means that this works, and I want also to search for the description. So the description should have this word as well. To do it, I will copy this, add it again, but this time I will add OR here. So this is an OR condition. Description will like this word again. So if I do it like this, we will get more items. Now we are returning 3. If I send a request, we are returning more items. For example, this item doesn't have this word in the title, but it does have it in the description. So this is how search works. Now let's add the other filter, which is the sorting. So we want to sort by the price in ascending or descending order. So let's do it. Let's get the sort also here. So I'll copy this, paste it here. This is sort, and if the sort is set, we want to order. So to order is pretty simple. Query order by price, which is a column, and in the order of the sort. We will have a problem here because it expects this to be an order direction, etc. But I will cast this as any, and that problem will disappear. So if I do it like this, this means that we can sort. So let's add here sort ascending. As we can see, the first item has a price of 0, 0, 1, 1, 2, 3, 4, etc. So this is ascending order. If I sort them in descending order, we can see the price 99, 85, 84, etc. Also, we can search and sort at the same time. So if we see we have less items, but they are sorted in descending order. So this is how we search and we sort. And now let's add the last part, which is the pagination. So we want to get the page as well here. I'll create a variable page, which is a number. And we want to get the page here. And by default is 1. So we have a problem here because this needs to be cast to an integer. So I'll parse int here this request, and I will declare it as any. So like this, we got the page. We need also another value per page, which is 9. So I want to paginate with 9 items per page. So to do it, I'll change the response body this time. The response body will be an object, and we want to return the paginated result in the data property. And to paginate, we have to use offset and limit. So we know the limit, which is per page. We want to return 9 items, so that's it. Now we need the offset, which the offset will be dependent on the page. By default, if the page is equal to 1, the offset should be 0, so we are starting from the beginning. So the offset will be page minus 1 times per page. So by default it will be 0 if the page is 1. If the page is 2, it will be 9. So we are starting from the 9 item, which means the first 9 items, then the next 9 items, and then the next 9 items. So if we return this, we can see we are returning from 1. So let's remove the filters. From 1 to 9. If I send the page to 2, we are getting items from ID 10 till 18, so the next 9 items. Still, we need some extra information here, like the total of the items that we are getting. And to get the total is a little bit different. So we have to make another query to find the total. So I'll duplicate this and I will create count query. And this count query, I will use the same filter as this one here. And in the end, I will get the response. So const, it will be an empty array, is equal to wait count query count. I want to count the ID because this needs to have a parameter here. Execute. So this will return an array with the result that we want, but the total, so we'll create a variable total here, which is a number, is equal to result, because this is an object what we return, and the total as a number will be the result with the key count products dot id. So this is how Kotlin works. Is not me that I wanted to return this result, and since the total is a number, I'll cast it as any. So let's return the total here like this and see if the response is correct. So if we send a request, total is 50 items. So this works fine. If I send also the search parameter, total items is 8. So we have to go to page 1. Total 8. So the total works fine. We need to return here also the page. And we need to return, which is also very important, the last page, which is equal to math ceil total divided by per page. This is also required to the front end. So if I send this request, we'll get the total, page, and last page. So this is how we search, sort, and paginate. I hope you liked this tutorial, and if you did, please also share and subscribe. Thank you.